Okay, so today this is gonna be a fun one. I'm gonna talk about this charge controller. This piece of units, you don't need to stress yourself too much. You can have a clue here that this guy is burnt. So the next question is, why is it burnt? But before I go into explaining that, let me still go back to tell you the details what this charge controller is all about. This is an mppt charge controller. So what solar charge controllers does, mppt versions, they take in input voltage from solar panel, run a buck conversion, and then turn it into a low voltage with high current that is suitable for powering or charging the battery. Now in this one, they are divided into blocks. This block here, the whole of this unit, is what you have as your SMPS voltage generator. So this is going to take in 12 volts from any source, solar or from battery, generate a desired voltage to power a chip that is going to do the buck conversion. So the chip will now start operation, and with the help of this MOSFETs here and here, the driver's chip, the buck converter chip, whatever name you like to call them, they will switch these guys at high frequencies. They'll switch this MOSFET at high frequencies and bring out the desired output through a coil, which will now be used to power your load or charge the battery. In this case, the driver's chip can be found on those uprising cards. You can see that one there is burnt. You can see it clearly. It's burnt. There's a burnt mark around there on a resistor. I don't know if you have this board. You can also look at it so you can see it clearly. Okay, it's sharp enough now. So you can see that young man there. There's a burnt mark around that guy. So you test it to confirm that it's good. It could be the capacitor, the filter, or the bypass capacitor that filters the power or the voltage to this PWM or buck chip. Yeah, that's one of the chip, and this is another one over here. You can see it. So there are two of them. So if too much current is taken from this transformer, it is gonna burn, and when it burns, the unit will now no longer be able to sense solar. That's what happened. So this unit here is the microcontrol unit that will take sensing for current and for voltage input and output, and then send that information to the screen. Yeah, so if you should have that false, that's where to check out for. Okay, there are a whole lot of other section. This is a relay, and this is your input terminals for battery and for solar. I don't know if I can get that close. Okay, you can see the labelings there: bat minus, bat plus, solar minus, solar plus, and this is your RAM temperature, current sense, and all of that. Yeah, those are not necessary. Yeah, so these uprising cards are the driving section to these MOSFETs. So you can see all the drive circuitry is there, and then this other side too. Now in this other card, there are a bunch of other components that are there that will be sensing and doing a whole lot of work. Like you see that U4 there, it's not a driving chip. That U4 there, it's something else, but I'll have to zoom in to see if I can identify that component. Let's see. Can we identify 358? Okay, 358 means that it's an op amp. It means it is an op amp, operational amplifier. I don't know if you can see that clearly, but I can see 358. So it's an operational amplifier. So if you look at this in comparison to the 5 kilowatt power models, you can tell that it's the same thing. They are using the same scheme. They are using the same methods to operate. Thank you for watching, and give us a thumbs up if this was helpful, and we'll do another video where we fix this. Maybe in the nearest future we'll drop the video. Also subscribe to our channel for more videos.